We have a few connections yet to solve at Site Connect because Site3D didn't solve them for us, and those were, of course, the ones that we have already signed, this one, but also we had just to solve this one in the middle, and of course, the ones with the angle sections. So let's take a look at how to design those. If I come and edit node 29, either here or at TrueBeam Steel, we can start designing the connection. Remember the drawing sections to make them see-through or not. So this connection is going to be very similar to the one that we have already created. It's going to have an end plate that's going to connect P1 to V1. This time we're going to use F30 of steel, and we're going to give it a thickness of 10 millimeters to the plate. And same overhangs as the last connection, 15 to the top and at the bottom, and then 35 to the left and 35 to the right. Since it's about the same connection, we're going to make use of this time to really demonstrate the bolts operations that we previously commented but not entirely demonstrated. So if I make the bars see-through, we can clearly see the X and Y axis of the plate. And we're going to start by commenting the generation of bolts by polygonal, and we're going to give it a number of 4 and find out why we haven't used it. So with 4 sides and a radius of 75, we can see that there's no way we could tell when we're generated that the bolts are not in the 0, 0. Maybe by coming here and saying 45, let's see what happens. This would rotate, but again the distances are 75. So if we are happy with that, that's one way of doing it. The way to delete all the bolts that are described would be coming here to this icon and saying delete all. Let's see how we could do it with the other operations that we said and generate rows and columns. So maybe if we change the projection first to X and Y, we can better see this. So if we're looking at the plate as this, X and Y in the vertical direction, and we click here, we will be looking at the sort of the same thing as the drawing. So if we say 2 rows and 2 columns, we can see that the first distance that we have to give, SFO, would be the distance from the 0, 0 coordinates in the Y direction. So in this case, that would be minus 60. 60 would be if the first bolt was up here, but since it's the Y axis grows in that direction, then this distance 60 is going to be negative. And since we want them to be at a 60 millimeter distance from the center, we're going to give it then the SF distance is going to be 120. So we'll have one row of bolts in minus 60 and the other one at 60. Here, if we wanted to create the same as we had in the previous connection, we would have to define SCO minus 75. So from the 0, 0 coordinates, which right now are in the middle of our section. We want the first column to be placed at minus 75, and then the other one at 75, and for that we have to give them a separation of 150. And of course, give it 0 degrees from what we have designed. So those are two other different ways of creating them. And last but not least, we have to weld P1 to the plate, and this connection will be solved. Let's take a look at how to solve the one with the angle sections. But before that, the angle sections right now, if we edit the node maybe N25, we can clearly see that the sections are not in the same plane. Okay, this is because of how we describe them at CYPE-3D. So one thing we can do to solve this connection is actually deleting the angle with respect to the XY plane. So please edit the node, not the connection, edit the node and delete that angle. Let's 0, 0, and 0. And now that they are all at the same plane, let me make this a little bit more visible. We can start working at a plate to unite them. Maybe this connection is not the best answer. It's just one option. If you have other ways to solve these ties in crosses and connections, you can try to solve them as you would really do it. And we're going to describe a plate. The material, we're going to select F30. The thickness is okay if it is 10 millimeters. And this time, instead of rectangular, we're going to select circular type of geometry for the plate. And we're going to make it 350 millimeters of diameter. And now, using the position type, we can say it is attached to any of these bars flange. So that would make it positioned like that. And now to start connecting, we first have to solve that they don't really reach each other. For that, we're going to use reference planes. We're going to make reference planes perpendicular to each bar. Let's see, minus, no, without the negative, I'm going to make it. So first, I'm creating a plane of reference that is perpendicular to V1 at a distance from the node of 80 millimeters. Let's see if that's enough or not. We can correct it. So since we're going to apply the same operation to each bar, I just used copy operation right here by clicking on copy. You can copy it and just change the bar. So in this case, we have done the operation for V2. Let's copy it again with this option and change perpendicular to V3. And last, copying it to V4. Let's see if that's enough. And to see it, I'm going to adjust each bar to its reference plane. So V1 to reference plane 1, and that bar will be cut by the reference plane. Copying this operation and changing to V2, we can say the same thing, V2 to plane reference number 2. Adjust B3 to plane number 3, and we're gonna do the same thing to V4 with plane reference number 4. Now that they are all cut, we are going to bolt the sections to the plate. Using just straight bolts operation, we can select that we want to bolt V1 flange to plate number 1, and we can start adding the bolts. So 0, 0 is the center of the plate. Since we have got it at 80, maybe the best thing is to start at 100 or maybe more. That's up to you, and you can copy this bolt and say 130. If that's too close and you want them farther separate, then we can do that. And let's copy the same operation and use it for V2. And let's see if the other two also are fine with what we have described. Seems like it. And V4. And now we have them all welded. Maybe see for B4 that didn't work. We have two options. We can either make the plate bigger or change the separation of the bolts. I'm going to choose making this plate a little bigger, and that way we can make sure that these are okay.